So I'm going to get into all the sorts of different types of networking stuff. I know Weissman went over his first week a bunch of like the basics, like how IPs work and all that stuff. And we're going to get into like the concepts about like what actually goes on in a network and how to secure a network.
So you're not going to throw markers?
No, I'm not going to be throwing markers today. Oh no, go next slide. Hold on. Alrighty, what are you looking for? Alrighty. So, let me back it up. So we're going to hit the devices. They're the main devices that are on a network that help you defend it and that control the traffic. We're going to go over a bunch of these terms because these are all extremely important terms for you to know. And then we're going to go over some like practical Cisco OS stuff, which kind of leads into the demo this week. So first what we got is we got the gatekeepers of the network, the router. The router is your first line of defense. This is what gets hit first with all the traffic that's coming into your network, and this is the last thing before any traffic leaves your network. So its job is to route different packets throughout subnets on your network and also take in the ingress and egress traffic. So we'll go over that in a second. If any of the router is down at all, you're going to have a huge problem. So this is an extremely important part of the network, and it is the backbone of everything. Make sure this thing is always up to date. Make sure you limit your administrative rights to it, and make sure that you keep logs from your router. It's a very, very good idea to have logs for your router. Next are your firewalls. This is like, they protect, they're like a border in your network. You can set these up anywhere in the network. A lot of the times people will set them up before their router. Sometimes there's firewalls are built into the router. Sometimes you put them after the router. Sometimes you put an extra one between certain networks in your actual whole network. So this is where you want to place these wherever there's an untrusted like network, and we'll get into DMZs, but that's going to be pretty much the main use case of these firewalls. And again, you really want to make sure that these are patched and up to date, and that you have good rules on them, good firewall rules. Because if you don't have good firewall rules, either stuff will just go right through, or you'll actually drop legit traffic, which could be a huge problem. Oh, what the hell? Hold on. Please hold. Oh, switches. So switches. This is the third line of defense. This is what. I'm sorry. Hold on. Where's the mouse? There we go. We're back to full screen. This is the third line of defense. This gets all the layer 2 traffic. This routes all the layer 2 traffic. You can add more like access control lists here and more not really firewalls, but you can route which layer 2 packets go where with these devices, and they're extremely important for like actual internal communications on the network. So now that we know the devices, we're going to talk about some terminology. So this ingress egress is an extremely important term to know when you're doing networking. Ingress traffic is any traffic going into the network or into a device, and egress is anything going out of the device or out of the network. So if I'm saying the ingress traffic to the router here, it's going to be any traffic going in, whether it's from the WAN, which is the internet, and then the LAN. It's still ingress no matter which way. As long as it's going into the device, that is ingress. And then egress is out. So it's a super important term to know. A lot of people don't know the difference between stateless and stateful firewalls. This is extremely important because it will determine how you set up your firewall and the different rules that need to be made in order to protect your network. So stateful keeps track of the state of the network connection. So it watches each active network connection in its state table. In its state table, it tracks if it's allowed for that connection to go through and do a full completion. So for example, if you have an outbound rule to port 80, but you have outbound or inbound port 80 blocked, and you make an outbound port 80 connection, it will allow the specific outbound port 80 connection you made to come back in. So you can still block it on the outside and then make the connection, and it keeps track of the state. Windows Firewall is the big one for stateful. There's a bunch of other ones. It's very intense on the compute side. Stateless Firewall analyzes each packet that goes in and out of the network. So if you have a packet coming in that's blocking, it doesn't matter if you've already had a connection going. If you allow a connection out, and then there's a connection coming in, and say it's SSH, like you have your SSH connection out, or ping, for example. You'll send a request to the machine, it'll allow it, and then it'll send it back, but you won't actually receive that because you have it blocked. So that's stateless. It analyzes per packet. And it was not as verbose, but we'll go through a lot of examples of this later. So we'll get to that. NAT, if you're not familiar, it's network address translation. Network address translation is super good because, say, you have your public IP address. I should have put a picture in here. That would have been helpful. You have your public IP address that hits on your router, and then you have a bunch of different hosts behind it with other IP addresses. And you can even do it again, like a double NAT, where you can have another router in your network and then use the same IP addresses even deeper down in the network. Really wouldn't recommend that. It's awful and terrible, and you should never do that. But that's any pretty much, except RIT, usually home networks are NATed. So you have your private IP addresses like the 192.168, the 172.16s, and like 10.0.0.0, whatever. So a lot of those are the local addresses, and they translate into a public address. Everything translates into a public address when it leaves your network, the egress traffic. Then there's different kinds of nets. There's one-to-one translation. One-to-one is when you map from the router a public IP address to a private host on the network. So if you have a private host on the network that's, say, hosting a web server, the one-to-one, you can translate it to send all traffic that the router gets to that host. There's also one-to-many. So say you have a web server and an SSH server and then like a VPN server all running on the network, all on different machines. You can set up a one-to-many, which is what port forwarding is usually used for. And it sends different ports that hit the router will go to different devices on the network. So that is a one-to-many translation. So now you have multiple services running on different devices, all at one IP address. Real quick, I'm not going to touch on this too much, but I think it's an important concept to know. Collision domains are not really present anymore because hubs aren't really a thing, because why would we use a hub nowadays? But broadcast domains are important because that is the reach at which everything can receive a broadcast message. That's something to keep in mind is broadcast domains, and those are entire subnets. So for example, this right here is an entire subnet. This is also an entire subnet. And you can see the little collision domains, but again, they don't really matter with switches as much anymore. They really are with hubs because hubs broadcast everything. All right, a DMZ, a demilitarized zone, or the perimeter network. A lot of people, like when they think about this, they think of, oh, the safe space. The DMZ, when they're talking about networks, is not the safe space. The DMZ is where all the public services are hosted. So yeah, as you see with the diagram here, we have the internet, and then we have one of those firewalls, lovely firewall. And then we have our DMZ right over here. The DMZ includes a web server and FTP in this case. And these are exposed to the internet. They're still in our internal network, as you see by the IP addresses here, but they're all on their own area. And for any of these to reach the LAN over here, you have to go through the firewall. So this way you can really monitor the traffic going through these. So the DMZs, this is considered an untrusted part. When I say untrusted, this is what the DMZ is. And then you have your more trusted part, your LAN. So now we got LAN, VLAN, VXLAN, WLAN, and WAN. So these are just a bunch of terms that are thrown out around a whole ton. LAN and WAN are the basic ones. There's a local area network and a wide area network. Wide area network being the internet, like ISPs. Local area network being like, say, your home network or any other network you set up. So then there's virtual LANs. So if you're unfamiliar and haven't heard of a virtual LAN, normally when you separate like network subnets on a network, you have the whole separate switch for it, but then they decided that was way too painful, so they made a virtual LAN. So now you can have a bunch of different subnets all on one single switch. That's what you'll see up in the labs. You'll have a 24-port switch, and you can have however many subnets you can fit on there. So that's what VLANs are used for. VXLANs are a lot of times found in cloud or in like VMware virtual switches. You'll see those. I'm not super familiar with those, but that's where you'll actually see a lot of them. WLAN is a wireless LAN, so like if you plug in a wireless access point, you can set it up to have its own like wireless like network and assign IP addresses as a LAN just to that subnet. Oh, Elijah asked a question. Sorry I missed that. I didn't have the Twitch chat up. Can one-to-many NAT be used to obfuscate who is doing what? Possibly, I guess. I wouldn't rely on that. It's not really meant to be like obfuscation tool. It's really meant to be a way to get more IP addresses and then like share services between all of the local servers while not exposing one or hosting everything on one. It's really like a solution to hosting, not really a obfuscation technique. Oh, did I skip a slide? I did. Yeah. All right, client VPN. There's two types of VPNs, site-to-site and client. Client VPN is when your VPN client goes through the internet, through the gateway, and goes to the server. So there translates it to this server right here, this VPN server. This VPN server then gives you a local address, and then, as you can see in the diagram, it moves your laptop right here, your computer down here, when it's connected to the VPN, and it puts you on the LAN. So when you have a client VPN, it puts you on the LAN then. It gives you an IP address and translates you to the LAN. So now you have access to this network. There's two types of client VPNs. There's a full tunnel where all your traffic will go through the VPN server. And then there's a split tunnel where only some of your traffic will go through. Site-to-site. So site-to-site is when you hook up two physical locations, two different physical locations to one another through a VPN tunnel. These are super useful if you have like businesses and like all throughout the country or all throughout different physical locations, and you want them all to use the same like services. You can actually link them all up with a site-to-site VPN. So for example, here you have this site. Site refers to physical location. This site, and here's the open internet right here. There's the routers, and then they actually have a VPN tunnel. The routers have a VPN tunnel to one another. So now the traffic will travel through the encrypted VPN tunnel with like encrypted, like encapsulated traffic instead of just over the internet, and they can actually access each other's services. So this computer can access this server just fine. Okay, so now how do we turn it into actual defense? Like how do we translate this to defense? So practically, a lot of the operating systems you're going to see are Cisco. At least here you're going to see our Cisco, and you can get a lot of hands-on experience. I think there's Junipers also up in there. I'm not really familiar with how Junipers work because a lot of the labs were Cisco. But we can sit down at the router. What are we able to do? So we can change passwords, and we want to make sure we can elevate to all of our different privileges if we're going to be root and configure. So there's 3 different levels. I think they get into it the next, right here. Is it here? No, it's right here. So there's 3 different levels. Enable brings you down to like the root level of the router, and then there's configuration. I forgot what the T stands for. I always just do config T. And then the terminal, configuration terminal. All right. And then when you go to config T, this allows you to configure the different like everything on there, like interfaces, different VLANs, subnets, etc. Everything can be taken or done there. So we want to make sure that we also have, like I said earlier, passwords enabled. We want a password on our device. So what makes a network secure? We have to use the protocols, only use the protocols that we are going to be using. Don't allow ingress and egress for things that don't matter on our network. If we only have a web server on our network, we should probably only allow web server traffic to hit our computer if that is what makes it usable. You have to balance this with what makes it usable and what makes it like secure. So you want to disallow as much as humanly possible. In my opinion, you should really block ICMP pretty much altogether, with the exception of what you would need, because the ICMP traffic, as you can see here in this lovely picture, I know it's a little small for those in person, is all pretty much deprecated at this point. A lot of these are deprecated, so there's really no reason to allow a lot of that stuff. What we got here? Oh, strong passwords. You want passwords everywhere. Do not leave default passwords on things. If you find default passwords on a network as an attacker, that's just easy money. Like everyone, I mean, it's the first thing I do when I pull up a network device or any device. Really, is check the default passwords, like the proprietary default password. On the network, and that's not even at a network, a router level, but disable services that are not. I know we talk about stuff like this all the time. Disable services that are not like being used. Make sure your traffic is being logged. A lot of the time, a lot of the different devices all log traffic to their own personal devices. You normally want to centralize this to one logging server. And I'm sure we could give a whole talk on logging. But as a general rule of thumb, you want to centralize all these logs to one server so you're easily able to access all of them and digest them all. Access control list, and we're going to get into access control list way in depth because access control lists are extremely powerful, and in competitions will be super useful. Again, default password on the network devices, super, super important. Make sure you use the right hashing. It's been a minute since I've changed the hashing, or what hashing you use on Cisco OS, but you need to change it to the proper one. One of them is just not even worth using or even hashing your password. It's pretty much just plain text. All right, here's a tree structure of the commands a little bit. So like I said at the beginning, this is like the user level, very basic. When it has the caret, you have to go to the enable level, which brings you down to your privileged. It is, again, like I said, root, and it allows you to move to any configuration or view any of the system stuff on the router or any of the switch, any of the network devices you're on. And then when you're in the configure, you can actually change these things. You can actually configure all the stuff that you can view as the root user or the privileged user. So ACLs are super important, like I keep saying. They allow you to permit or deny any traffic based on a variety of things. The main ones are as listed. But yeah, you can have one per direction per interface. It's super important. You don't want to allow ICMP like in and deny ICMP on the same one. It just doesn't make sense. And then once you apply them, they're good to go. So be careful when you're applying them if you don't have physical access to the device, because you could completely lock yourself out, which is not a good time. If you're using like remote configurations, that could be a bad time. So guidelines, when you're doing these, they do sequentially. So they do top down. They go all the way down until they find a match. Once it finds a match, it does not go any further down the list. So you really want to make sure your most strict rules are at the top. So let's see, make sure I cover everything here. Yeah. All right. So yeah, we're going to get into like details of making an ACL here in a second. But make sure that if you don't want web traffic, don't have an allow web traffic right above it, or allow like something related to such above, because it will just ignore all the rules below. So again, we're going to hit ingress egress, which is a very important term that a lot of people have not completely like understood. I took a while to understand these. It's into the device. So ingress egress into the device is how these rules are applied. So they can be used to filter both in and outbound rules into the device. So if you can have like ingress egress on your switch and ingress egress on your router, and they can be completely different. So they also have to be checked against every rule, and you can use them to stop malicious traffic at each level of the devices. So if you can also lock down a certain device if you don't want any traffic from, say, your 172.16.0.1 or 0 network to go to your 172.16.1 network. You can completely block those two from talking to each other at the switch level, so you don't have any problems with that. None of it actually gets routed. Oh, 1 second. Ooh, ooh, that's a little much. There we go. It just switches sometimes. It's super cool. There we go. Alrighty. So there's a standard ACL. Super simple, not a lot of control here. List 1 through 9 are simple ACL, or list 1 through 99 are simple ACLs. It's a simple permit deny from a source address, and that's about it. That's pretty much all you can do with a simple rule. So pretty much you don't want to hear anything from this address. And then there's wildcard masks, and I believe there's a slide on wildcard masks in a second. No. So I'll explain there is definitely one later. But do a quick, it's like wildcard mask is the opposite of a network mask. It tries to decide which bits need to match. So I'll get it. There is a complete slide like it's showing an example of what that is. So I'll get back into that in a minute. Extended ACLs is what you'll actually probably see a lot of because these are thick. You have lists 100 through 199, the permit and deny, and then you can do protocols, you can do the source addresses, you can do ports, you can do destination addresses. So there's a lot more you can do with these, and they're a lot more powerful. So these are really probably what you're going to need, unless you just need a simple don't go here. unless you have a simple don't go here, this is probably what you're going to end up using. Here it is. Perfect. So wildcard mask is what network bits need to match in the ACL for it to actually block it. So what is considered a match? Because say we have, okay, router, block all 192.168.0.1. What will that block? Well, if we have all zeros, it needs to be that exact match of 192.168.0.1. But say, for example, we want to hit just the whole, like 192.168.0.0/24, like that whole blocked subnet, we would use this one here, the 000.255 right there. So that will tell us, okay, it needs, if the any network traffic that comes in that is 192.168.0, it will block any, that last bit does not matter. It could be 1, it could be 255, whatever it is, it's a match, and it will drop that, like that packet or that frame, depending on what layer you're on. So it can just, if you work your way down, it's the same as a network mask, just in reverse. So if that's how you find a match with these wildcards. What's the reason for having 99 access lists? Asked Bradley. Some networks are big. They're just big. You can have any number. Oh, did Ian answer it? Yeah. Thank you, Ian. Yeah, some networks just be built different. Oh, okay. The network guy knows what's up. How many rules can be allowed to list? As many as you want. I don't know. There's a lot. I mean, you can probably add a lot. I'm not really sure. I haven't really limit tested the ACL list. Yeah, I mean, you have to realize when you add, like, say you add like 100 rules, it has to go through every 100 rules until it finds a match or hits the bottom. So like the more you add, the more intensive your ACLs are. So yeah, and it's gonna be a lot of latency. If you say you have a computer and then a switch and then a router, if you have say 100 ACLs, and I'm sure you could, let's scale up to 1,000. You have 1,000 ACLs, and the packet or the frame doesn't match all those ACLs. It's gonna have to go through all of them, going in and out. Or if it's their ingress and egress, it's gonna hit each one going out, and it's gonna hit it again, hit the router, and then it's coming back in. It's gonna do another check and then another one. And if it doesn't match any of those rules, you're gonna get a ton of latency just because there's so many like unmatched rules. Did I even hit this slide, or did I get distracted by the question? Oh yeah, no, we didn't do this one. You have to be careful. When designing ACLs, it's very painful, especially on Cisco, because there's not a GUI. You have to input them manually. So make sure that you kind of write down what you need to block and in what order you're going to actually do it in before you start typing into the console. Because if you start typing in the console and realize it needs to be different, you're going to have to make a new ACL, like a new access control list, or you're going to have to finicky delete rules and then add them from where you were. So just make sure you write everything down. Oh, wrong way. So we're going to go through an ACL journey here from that client to this server. It's beautiful. It's a NATed client and a NATed server. So we're going to send the traffic over. So we're going to watch the traffic go through, and then we'll talk about how we can handle that. So there we got the source address here of this device, and it wants to go over here. And then the computer, when you go to connect to a server, it generates this random port for you that is not going to be used. So that whatever this, I don't know how to pronounce that, but that's what it is. It's a random port number by the operating system, and it uses that to establish the connection between the devices. As we're going on through here, we'll see it hits the router. It's an ingress rule in the router, so it does an ACL lookup, and it does its NAT translation. So if it is all good, though, if it's all good, it will send it on. It changes the source IP address, and it will send it on to the other router. Because with NAT, remember, with NAT it changes the address. It maps that top, I would say public, or that outer IP address of the router to different addresses on the inside. So it changes it. Now it goes through. The other one receives the request. Again, it's ingress traffic into that router. So it does that check, and then it looks up an egress check after it does the translation. Boom, there it goes, hits the server. We're good to go. It generates its request back, and then there we go. And then it does the same process doing ingress check, egress check, ingress check, egress check. So look how many times it hits an ACL list. So it could have been stopped at any point at that time. So you want to be super careful when you make these, but they're also super powerful for blocking traffic you really don't want going anywhere. Cool. So what are the things we're going to need to, is this a repeat slide? No. What are the things we want to consider? What are we actually going to have coming in? So even in the real world or competition, what is supposed to be coming in? In competition, you can tend to be more strict. But like, what is actually going to come in? Do we have clients coming in from different IP addresses? Do we have web requests coming in? Do we have SSH? Do they need to SSH to certain machines? So like, we need to be conscious of what is legit traffic, because at the end of the day, if the legit traffic can't get through, there's no point to even having like internet connection if you can't actually use it. So you need to consider what actually needs to get through when you're making these rules. Also, same. What are this like IP and the source port of legitimate like things that the internal network needs to go to? So these are both things that what is legit coming in, what is legit coming out, and then you can go from there and start blocking anything that isn't needed. If you don't have an SMB share on your entire network, it does not. You can not even consider that. You can just deny all, get a list of all your services, and just only allow these. All right, cool. So we talked a lot about like ACLs and like what they're good for and how like they work and a bunch about all that. But like, how do you actually put one in place? So you can show all your access lists with the show access list command, and then you can show IP access lists, and it shows all the commands right there. So now how do we like get into like actual like digging into that? So you have to go into the config T. Remember, we do all of our configurations in config T. And then from there, we can start plugging in our rules. So there's a simple access control right there. We on list 1, we add a deny for this source address with this mask. So any addresses that are 172.22.50/24 subnet are going to be applied. And then we have a permit any. Does it go? It goes from top to bottom when you add them, right? So this permit any's at the top.
No, it's at the bottom.
Oh, it's at the bottom?
Yeah.
All right.
If it doesn't match that, then it'll be allowed. But everything from that subnet.
Okay, that's what I thought. I was a little confused for a second because I was looking at it last night and I was like, that makes sense. I questioned myself. Okay, cool. So now after you add to the access list, you go into the interface, and then boom, you can apply it to the interface. And then, see, we applied it to the outbound, the egress interface, though. The egress of the interface. So it's a per interface type of ordeal. So cool. So now how do we view of that, for like stuff for that interface? You show IP interface, and it shows all the details for the interface. And there you can see we have the outgoing access control list of 1, which is the one that we just added to it. So removing an ACL from an interface. Say we applied an ACL and it no longer is applicable, or we don't want it, or we realize we made a mistake, but we already applied it to the interface. A lot of things in the Cisco OS, you can just put no in front of the command you used before, and it takes it away. So to get rid of that, same thing, we get in the config T, we go to interface 1, and remember we put in IP access group 1 out. Well, now we're just going to put no in front of it, and now it's deleting it. But as much as we talked about ACLs, they're not the end-all, be-all, like silver bullet. They're not enough to do everything, because you can only block so much with an ACL. Say you're blocking TCP port 80. Some malicious actor could be using port 80. So like it is not an end-all, be-all. But it really can you can use it to really take down your attack surface a lot and block a lot of the traffic going in and out of the network. Some other things you really want to do to like actually really start to like narrow down traffic is logging. So with the ACLs, you can block a lot of the traffic, and then a lot of that stuff will go to your logging server, and then your logging server, you can really narrow down the logs, and you won't have as much just like garbage, I could say, in your logs. But definitely want to be looking into like seam stuff. There's a lot of free seams out there. We used a free seam once, right, Nick?
Radar, but they're usually like to a certain extent they limit how many logs you can get per second, and once you go over that
Yeah, a lot of I was just talking to Nick because we did a project together with a SIEM with QRadar. There's a lot of them do like limiting of how many logs you can get, but like for intensive purpose of just using one and getting familiar, you can absolutely like just download one of those and check it out. There's also Snort, which is an intrusion prevention system. It's an IPS. So it's a rule-based IPS. So what that does is it takes the rules that like you put in place and it blocks it. A lot of the times these are also integrated into the firewalls, like the firewall devices. I know like Meraki, for example, has Snort integrated into its firewall device. So you can just turn that on and it'll just start blocking stuff. What's up?
For logging, on my Raspberry Pi, I set up like a Grafana server, and then had my router send syslogs to it, and you can like just use a Raspberry Pi and display that. If you're interested, I can give a talk on it.
Hell yeah, you want to just drop that in like Twitch chat, like what that server like was called. Nick just mentioned he set one up, a free one up on his Ras Pi, and just sent all of his router logs to it, and that he handled stuff that way. So that's a nice free way to do it. Who doesn't have a Ras Pi sitting around? I know I have a Ras Pi, and it's currently doing nothing. So I guess, does anyone have any questions about any of that stuff? I know I covered a lot of random terms, and then I went into the ACLs and how to apply them and like why they're important and all that. Anyone have questions about Cisco OS or anything like that? Okay, cool. There is a demo this week. Yeah, it is time. Emmanuel's tired. No, I can do it. I'll do it. Hey, you sit down. Hey, you're good. I'm going to stop the recording because this has nothing to do with the